Good day and welcome to our APDS POE Part 3 application. Today I'm going to be running you through the whole application and showing you all the security, database, SSLs, CI pipeline YAML files, and other features that we've implemented in our POE Part 3. So to start off, we can begin by running the server by using npm run server. Cool. Once the server is running, you can use the provided URL. This is running on HTTPS server. We've also updated the SSL certificates. It was issued on the 7th of November and will remain for a whole year. Looking at the homepage, obviously it will want you to sign up. This was done and covered in part 1 and 2 of the POE. We can go ahead and log in, however, into our account. Cool, my password was wrong. As you can see, validation is still working. And if I provide the correct password with the correct keys, cool, we can access our dashboard as a user. So as a user, we can go through here and we can make a payment. I'll make a payment for about $6.69. Let's make it a rand and provide our account number. Cool, the payment went through and was successful. We can then provide our account information with FNB and a Swift code, and we can save that account info. So the user's dashboards and pages all work as expected, like in part 1 and part 2. If we come through and sign out and go back into login, if you see over here, we can log in as an employee so that we can go through and actually verify the payments that have been done. So the employee data has been already preloaded, and I can come through here and log in. And again, you'll see there's validation that's taking place. The password for this user is just test at 0 and then 1 3 times. So 1 2 3. Cool. So on the employee dashboard, after you successfully logged in, you'll be brought here and you can obviously see all the payments that have been made. This is the most recent payment that was just made. I can come through here, click verify Swift code and verify. Cool, the payment has been verified and now we can submit it to Swift as well. And this works for any payment that has been made in the application. So you can come through again and submit it. Cool. So the data that is being displayed here on the dashboard is all being stored within our database. As you can see, we have the users table, similar to what we had in part 1 and part 2, which is just storing all the users in our system. Passwords are hashed. We're now also storing all the employees. So this is the preloaded data that we created. You can see all the passwords are being hashed. If you do want to go and create an employee for yourself, we have this file here, add employee, which can execute, I believe it's this one, which can execute just to preload any employees that you wish. Cool. So from the employees, we also have our payments. As it implies, it's storing all the payments in the system. Here's the most recent payment that was just made, as well as the account information that it's also pulling from. So that dashboard that you're seeing right here, the user data, their account numbers and things, when you land onto this page, it's making a request, and that API endpoint is pretty much collecting the employee data for when it logs in, and then it's getting the payments, and then it's getting the associated user and account information from that payment, so that the employee has full context as to what payment they're busy verifying and who it's for, obviously. So So taking a look now into our code, as you can see, I'm here in the secure server file, and this is the file for our HTTPS server. We have all our configs defined over here, most importantly, our SSL keys and certificates, and MongoDB credentials. Uh, Starting our MongoDB connection. So as you can see here, we're setting up the middleware. We're setting up express.json for application parsing, Helmet for extra security, and cause to ensure our requests. And we're ensuring that only requests made from the same origin is allowed. We also have rate limiting setup and brute force protection. And then finally, we're running that create server on the HTTPS. Additionally, we're getting all the built client-side code. So from the React app, once it was built, we're directing it, all the static files, to that build folder, and then also we're serving all of those files as well on that catch-all route. Additionally, we also have the API endpoints. They all use brute force protection, and obviously, because it's on the same app, uses the same middleware defined as above. We have our user controller, which obviously handles all the endpoints for a user, login, register, and getting a specific user. We have our payments controller, and our payments controller, again, has endpoints for get a specific payment, and creating a payment. In our get all payment, like I mentioned in the database, it gets all the payments and then loops over all those payments in a promise.all, and then gets the associated user, the associated account and associated user, and then returns it in a payment response object back to the client. One thing to note, all of our endpoints, they all use a response. So for example, this is a payment response. In the employee, it has an employee response, user as well, a user response. This pretty much just allows the client to know exactly what data type to expect from the server. So it just helps unifying all of that together. Looking forward, we also have our validators. So our validators just stores all the validation and verification that needs to happen, both from the user themselves and from the client, and from the client when they makes a request into the API. These are pretty much just a combination of ZOD schemas and proper validator inputs, little middlewares as necessary. Moving forward, we can move then to the front end. We created these two additional pages. Everything else was covered in part 1 and part 2. The employee login page just renders out a card with that contained employee login form. And this employee login form pretty much contains all the logic for that login. It returns that form, that's the UI for it. And then also has that on submit function. So once they click submit, this function will run and it will do a toast of promised, which is pretty much just that little toast notification that you saw at the top there, which will execute an asynchronous function and provide us a loading state, a success state, and an error state. In that success state, obviously, we're expecting that employee response data type. And that allows us then to manipulate the data as needed, as we now know what the defined data structure is. So looking into this method, actually, this login employee method is contained in this employee requests file. As you can see, each of the entities in our database have their respective requests file. So in the services folder, you can see the account request, employee, payment, user. And these files pretty much just handle and contain all the logic for making an actual API request, making an actual fetch request to the API, handling the error, and returning back the data as we expect it in the correct data structure. So the same is happening for the payments. So again, a function for the create payment, function for the get payments and show payments. And the same is obviously for the user and account. Another thing to note on that point, in our database folder, you'll find, again, all the tables, all the entities in our database. They all have their respective models. So, for example, this account model, it just represents the table that's in the database. So we define our Mongoose schema as well as just a normal account schema that we can use for validating and type safety. And then we have additional methods here that actually execute on the database level all of the queries that need to be done. So we have this create account, which does obviously it creates a new account and does that save, and then a select query so that we can find the exact account. The same is for the employee, same is for the model, same is for the user. It's handling all of those specific database queries for that table, and it's all contained inside of that one file. So that when it does come to connecting it to our controllers, for example, payments controller, it's as simple as just executing those files. I mean, those functions, and yeah, getting our data back and knowing that we can handle any errors that do occur. Moving forward onto the employee dashboard page. As you can see, we have the full page rendered out here. We have most notably this state containing all the payments. If you look into this use effect, so this use effect will only be run once. As you can see, the dependency array is empty, so it'll only be run immediately once the page loads. And this use effect is again using a toaster promise to run this async request to get the payments again in that payments request file. And we're providing that, all the states, the loading and success states. And again, this was most notable. We again know the data type of the response, which allows us to then store those payments in this payment state. So that we can render it out to the user. So you can just see we're doing the payments.map and just looping over all those payments and doing a payment card. Inside of that payment card, again, it just contains all the specific details for that payment card. Most notably, we have this dialog, which is what you saw there when you click on verify payment, and it will ask you just to double check that everything is right. And it will execute that handle verify method, as well as the submit. It will go on submit, which is just simply passed down from this parent component onto the props, and obviously handles all the process for verifying and submitting. Now, looking into our automated workflows, we have our Circle CI. Our Circle CI is using SonarQube, obviously. It's running these commands. So it's getting the Sonar branch, it's echoing out the values, and then obviously running the Sonar scanners and setting up the configurations as well. So defining the project keys, organizations, and all of that. Looking into our .github/workflows, we have our main.dev YAML file, which again has a bunch of jobs defined here. So it's running a test on the pull request, and it's running a test on the database. And then we also have our dev scopes pipeline, which again is running a bit more jobs. It's doing a pull request, it's doing a security check. So make sure that our node is set up correctly on the right version. We have the right dependencies. Our packages have been audited and meets the level of security that we expect. And then we're also running sync for additional security, just to catch anything that we might have missed. Next, we're doing code quality test. So we're just using ESLint to run those code quality checks. So to make sure that all the type safety and style and linting is done. And then we're using Prettier for the formatting, just to make sure the indentation and the code is pretty much clean. Next, we have a database test as well, which does as you expect, just runs the test to ensure that we can connect to the database using that MongoDB URI that we do expect. So yeah, that's our application for APDS Part 3. We hope that you like our application that we've developed. We've enjoyed making it. And yeah, we hope that you have a good day further. Cheers.